Hey, how's it going, everybody? Welcome back to the video course. In this lesson, I'm going to jump right into giving you a challenge, and I'm going to demonstrate how we can apply what we've learned with dotted decimal and binary and converting decimal to binary and binary to decimal. And I'm going to show you how this is practically applied in the real world or can be. So let's jump right into this. So what we have in front of us here is a network topology and packet tracer. This is representing a smaller network that has host requirements for both of the networks. We also given a larger address allocation that we're going to divide up based on these networks. This is a scenario you may find yourself come across in a network engineering or network administrator or system administrator role, where you're given the opportunity to build a network for the first time, to build a network, whether the organization's expanding or they're repurposing office space. And these host requirements, they will typically be based on some type of business requirement, like the number of employees in an office, the number of computers in an office. So that's where that host name will come from. In this case, I just picked a couple numbers to give you something to practice. So I will suggest that at this point, if you just want to practice this, go ahead and press pause on this video and challenge yourself to try to do this problem we have in front of us. If not, keep listening and I will show you how to do this from scratch. The first thing you're going to want to do here is you're going to want to figure out how many addresses are you actually given to work with. In other words, can this address space accommodate these two network host requirements, right? And the way that we do that first will be is where I'm showing you the method. I'm going to show you, and I want you to follow these steps, or at least try to follow these steps every time. The first step is we're going to think in binary. So thinking in binary, what do I mean by that? That means when I look at this subnet mask, or in Cedar notation being 24 bits, I want to think in binary, meaning I want to see what this looks like in binary. So I happen to know that, remember, every octet has at least 8 bits in each, right? So if we have 24 bits in our subnet mask, that means that we have 24 ones. Right? So what does this look like? This looks like this, right? So consecutively, we're going to have 24 ones. And I don't have to type out each of them. I'm just going to do this to represent 8 ones. I'm going to type 1 dash dot 1 dash, and I'm going to show you the third octet, right? The third octet is 1, 2, 3, 4, 5, 6, 7, 8 bits. And then the rest of the bits are going to be zeros, right? So 1, 2, 3, 4, 5, 6, 7, 8. The reason I did this is because the next step that we need to discover here is what our magic number is. You don't really know your magic number until you can see this in binary. Now, you may reach the point in practicing this where you can see a subnet mask and you automatically know what the magic number is per se. But right now, if you're a beginner and you're just practicing this, I want you to practice this method. And it's only a few steps. I'll show you. So once you find the magic number, and this is how you find the magic number, right? And you'll see why it's called the magic number. The magic number is the decimal number associated with the last network bit, which is, of course, the last one, right? Think back to last lesson where I had mentioned and emphasized the importance of memorizing 128, 64, 32, 16, 8, 4, 2, 1. Think back to that time. This is where it's going to really come in handy, because when I use that and I apply it to this octet, it gives me my magic number. So let me show you. So let's say we do 128, 64, 32, 16, 8, 4, 2, 1. What's the magic number for this subnet mask? Well, it's 1 because the last network bit, right? the decimal representation of the last binary digit is 1. So I'm going to put down in here, it's 1, right? The magic, we finished step 2. The magic number is 1. Now the third step, and this is actually our final step in what we're trying to do, is find the next network. So given that is the subnet mask, and that is the address allocation we've been given, we can know what the next network is by just applying this magic number to the exact octet that we found it in. And what octet is that? That's the third octet of this IP address. So that 86, we already know because we have found the magic number, that the next network is actually 10.3.87.0. So it'd be 10.3.87.0. Let me know if you have comments or questions. Put them in the comments. Reach out to me through Discord. This is where we know we can find the range now. So once you have the binary, the magic number in the next network, you know the range you have to work with. So 10.3.86, we know the next network ends at 87, right? So in this case, we'll say 87 network we're not using, it's out of scope. So let me scoot this stuff over real quick, just so it's out of our way. Now, what we need to do is find the range, right? So what's the range here? And you might have already known this. You were like, this is so easy, Bob. Why did you have us go through this? I'm making this video for those that don't find this easy already. Go through this process. I promise you, as you practice it, it will become easy. Watch what we do next. We know if this ends at 87, what is our range of addresses to use? How do we know what's available in our fourth octet? Because remember, what zeros represent are host bits. That means those are assignable. So those are, in other words, addresses that can be given or leased out to addresses on the network. So this is what's going to tell us that. That is 87. So if I were to think, what is the range? I already know, for example, this here is the network address. It represents the whole network. But what's the first usable address? So the first usable address would be 10.3.86.1, right? That's pretty straightforward. What's the last usable address? When I teach this is where people get caught up. They're like, I'm not sure, it's 255, 254. When I say usable, I really mean assignable. So what can we as people use to assign to a computer? That is, in this case, going to be 10.3.86.254. Now, why is this right here the last usable instead of like 255? That might be a question you have. Well, that's a great question. The reason we can't use 255 is because 255 is actually the broadcast address. Remember, in IPv4, there's always going to be a network address and a broadcast address. The network address is always the very first address in a network scheme, and the broadcast address is always the very last, at the end of the range. When I use the term usable, and really that term I should use the term assignable, that's different, right? So we always have to consider those things when we start thinking about what can be allocated, where, and what can be actually used by us. And, of course, when we start doing DHCP scopes and pools, we want to consider this. And a lot of times the software and the servers, they'll consider that for us in their allocation, but I do think it's still important for us to be aware of those boundaries. Now that we know, I'm going to actually remove some of this. So I'm removing this here. And then what we're going to consider now is these 3 steps for every single network. Here's where it gets even more useful for us. Now what we're trying to do is we're trying to figure out, okay, we've got all these addresses to work with. In this particular situation, we only need an address allocation that allows us to accommodate for a total of 38. This address, this scheme per se will give us a lot more than that, which is good. We know in essence that this isn't a trick question. I will say this, I do sometimes give an address allocation. In my classes, I'll give an address allocation, does not accommodate the host requirements. And I want to see if my more advanced students who understand subnetting will figure that out, because that's the first thing you want to consider. Let's start allocating addresses based on host requirements. This is a key skill. I've seen questions on certification exams that need you to know this skill. I'll say that. I've used this skill in the industry, not only to build new networks and design new networks, but also to understand what the boundaries were on a network that I was coming into for the first time. So it was a useful skill, and it still is. The question might be, where do I start? How do I start with this? Where do I go? Do I start with the 8-host network or the 30-host network? I personally recommend, if you're given a problem like this, or if you run into a situation like this, you will start your variable length subnet masking process with the largest host requirement. In other words, you're going to start with the network with the highest host requirement. And in this case, what would that be? That would be 30 hosts, right? Let me move this up a little bit. The 30 hosts network is what we're going to start with. We know we've got this address to work with. Remember this, even though we know what our range is and all that, we haven't used any of these addresses yet. This is our total allocation. So we can start here. Here's how we would do this. First of all, we know we haven't used the 10.3.86.0 network yet, so let's start there. We know we've got 10.3.86.0. What we don't have yet is the subnet mask, and that's the most important part. And that's the challenge. Given 30 hosts, how do I know subnet mask I need to use? Well, this is when we go into this process. We think in binary, we find the magic number, and we find the next network. First of all, we know we have to work within this boundary. It's going to fall in between here. But we're subdividing our network, meaning, that's what variable length subnet masks means. We're taking a larger subnet mask or subnet, and we're dividing it into smaller pieces. We're cutting the pizza pie into different slices here. And what we're going to do is we're going to think in binary to do this. So if we look at, let me grab my note taking thing, and feel free to follow along as I do this. If you have to watch this video again and follow me as I do it, do it. And challenge yourself as I do it, or pause the video and try it yourself. Do that too. The best way to get good at this is to practice it. When I look at this, I'm going to start doing in binary. I'm going to do 128, 64, 32. And I know I'm telling you, this is why the magic number process is so good, because we know in the 4th octet, it goes 128, 64, 32. How many addresses do we have to account for? We think the network address and the broadcast address. We mentioned that up here on the top right. So these are 2 addresses, right? How many usable or assignable addresses do we actually get with this subnet? Even though the magic number is 32, we have to think back 2 because of the network and broadcast address. That makes it 30, right? So this would hit us right on the head. Let's do that. Let's try to get as close as possible to the host requirement. What are the rest of the bits? Are they 1s or 0s? They're 0s. So it's 1, 2, 3, 4, 5, 6, 7, 8, right? The rest are 0s. Now we did the binary here, but we kind of did the magic number at the same time. We know what is the magic number here for this network. 128, 64, 32. That's the magic number. 32. What's the next network? And this already gives us this, because we have to remember, we have to work within the confines or the boundaries of this network. What's the next network already start at? You tell me. So where would we add it? How do you know? Think about what we did earlier. This is a challenging part. Remember, when you're thinking about where you apply the magic number, think about where you found it. You found it in the fourth octet, right? Because we're working in the fourth octet when we're considering this particular problem. Now we're in the fourth octet. This is pretty straightforward. We actually would add 32 to 0. Now we actually know what the next network is. It's 10.386.32. And, you might be challenged by this now, but you'll find that the fourth octet is actually the easiest to work in. The third octet, second, those get a little bit more challenging later on. We're not covering that in this lesson. We've got our next network, right? Already. I'm actually just going to Control C, Control V, drag this over here, and that's my next network. I already know that. Here's another thing we got to do, because if this is us designing our network scheme, I personally recommend get your network addressing first. If you're building a network from scratch, get the addressing right first before you start going and configuring stuff, because you don't want to mess things up, by not having a design, and document at the beginning too, and do it throughout. So start documenting in the beginning. Either way, what is the subnet mask in Cedar notation for this network? So think about it. You might say, well, I don't know. What do you mean? Well, remember what we've started working with is the first 3 octets are all ones, right? So if this represents our binary in the fourth octet, how many bits is this added on? This is 25, 26, 27. So this is a 27 bit. And I promise eventually you'll get so well versed at this that you'll have that memorized, but you got to practice it to get good at it. Remember. So cool. Now, our job at this point gets pretty easy. So now let's work with this one, this network here, and then we'll be done with this lesson. I'm going to get my delete tool, remove this, and this, and we're going to use our same steps of thinking with this particular network. Really, we already have our network address, and this is a network address. This is actually a number that will not be able to be assigned by DHCP or statically. This is the network address. So we're thinking in binary now. We're really combining these steps when we're thinking about hosts. With the number of hosts, what is our binary and what will our magic number be? Well, we have to start thinking, and this is why, again, I have you memorize the 128, 64, 32, 16, 8, right? So if I need 8 hosts, that means after subtracting 2 for the network address and broadcast address, I need to have 8 assignable addresses at least. Let's think about the binary here. We're going to do 128, 64, 32, 16. If I put a 1 here near 8, then I only have 6 usable, right? So that can't work. So it's 128, 64, 32, 16. 16, we're going to need the magic number 16, right? And then the rest will be zeros. So I'm doing 128, 64, 32, 16. Keep doing that. 128, 64, 32, 16. We got as close as we could given the structure that we have with IPv4. We can't pick the 8, right, as a magic number because we have to subtract by 2 because of the network address and the broadcast address. That would not give us enough hosts. We know already what the magic number is because we kept saying it. It's 16. What's the next network? The next network would tell you the range. So that's why I'm asking you to find the next network, is because then you know your range. You know your first available address, the last available address, and what you have to really assign to your devices on the network. What would be our CEDR notation for this network here? How do I know that? I go ahead and I look here at the binary, right? How many ones are added here? It's 25, 26, 27. It's a 28-bit. And you might have been, hey, I can do that in my head. I can do all this in my head, off the top of my head, because I've practiced it a lot. And truthfully, the only reason I can really go through this off the top of my head is because I've taught it for a few years now. It takes some time to really memorize this. It does. And just practice it and you'll get good at it. Now we have really all we need to know what our networks are going to be, what our ranges will be, and this is a nifty trick that we can use to go through that process. Let's just finish it up. What is the magic number here? We know it's 16, so we're trying to finish this by looking at the next network. What would be the next network? I'll let you pause the video and think about that. I'll show you how to do it. We know if we have 16, where do we apply that? This is tricky. This is where you would think you would apply it here, right? No. You've got to apply it where you found it. This magic number would apply in the 4th octet here, because this is the problem we're working on. What would that be? We would add 16 to 32. What is 16 plus 32? 48, right? What does that mean our network is? The next network would actually be 10, 3, 86, 48. So we're not using this network in this particular lesson because we only needed these two. But knowing what's next tells us what's in between. I can tell you what's the first assignable here, what's the last assignable. So let's do that, and then that'll be the final thing we do in this video. I'll start back here since we didn't do that here. If I'm looking at this network, what's the first assignable or first usable? Let's start using the term. I'm just going to keep it consistent by doing usable, but you can also consider it assignable. This is where it's like, okay, I'm not starting at 0 anymore, so I have to think 32 is the network address here. That's why I put it as in CEDR notation to represent the whole network. First usable address over here is 10.3.86.1, right? Which is normally something you'd give to like a router. Normally, a best business practice or a common business practice with assigning addresses is with a router. The default gateway in particular typically gets the first usable address or the last usable address, right? So we know the first usable address here is actually not 1. I'm sorry, it's 33. 10.3.86.33. And then the last usable address what would the last usable address be? Would it be 47 or 46? It'll be 46, right? Because 47 would be what? The broadcast. You got to think about the broadcast. And this is where it can get a little bit tricky because now you're working with numbers you may not be used to. Because one of the most common address schemes is like 192.168.0.0 with a 24-bit. So you're always working with 1 through 254. But when you start getting into bigger networks, where the network engineers use subnetting and they use VLSM, which is, again, variable length subnet masking, then you start to see these different numbers and it may be confusing. But with the same line of thinking that I showed here in this lesson, you could really do subnetting given any problem. I hope this has been a helpful video. Let me know in the comments if you have any questions or you feel that you have a better way to do it. This personally has been a way that worked really well for me. I'll see you in the next video.